Okay, so this is going to be 2014 number 2. This is the volume question, and you will have a calculator for this. You would have had a calculator for this. This question seems, the part B I think is the toughie here, but it's not so terrible if you really practice with the cross-sectional problems, because they're all kind of the same. Okay, so the first part, well, what we know is that we have f of x equals x to the fourth minus 2.3 x cubed plus 4, and the line y equals 4. And we have this little drawing here. Mine is not 100% accurate, but that's okay. And we know that the region is this guy. I'm going to put it off to the side because I'm going to draw some stuff later. Part A asks us to revolve around y equals negative 2. Okay, so I'm going to draw y equals negative 2 down here. Now, there's all this space in between these curves and y equals negative 2. If there's a lot of space there, that means it's going to be a washer, if you're still unclear about the difference between a washer and a disk. So, because what I'm doing is I'm kind of taking this and it's going around like that, okay? So you need to find little r and big R. So if you just draw lines from your curves to the line you're revolving it around, the bigger one is big R and the little one is little r. So it's basically going to look something like this, right? With this, right? This is little r, and this is big R. Okay. Actually, what I should do is you can't undo when you're videoing. So, so there's little r and big R. Okay, so little r is the difference, the distance from this curve to y equals negative 2. So it would be the area under here, like right from this curve to the axis, plus this extra 2 business. So little r is x to the fourth minus 2.3 x cubed plus 4, and then plus 2, because that's the extra space. Big R is going to be 4, right, the area under here, and then the additional 2, so 4 plus 2, which is 6. So we know that when we go to set up our volume, it's pi times, so we want big R squared minus little r squared. Now, the limits of integration go from, right, they go from 0, this is supposed to be 0, 0 to this. Now, if you're wondering where this curve intersects y equals 4, you're going to have to find out. So what you do is you just plug in 4 for y, or you can just do this on your calculator. In fact, I would do this on your calculator. So find intersection of y equals 4 and f of x on calculator. Okay. That ends up being 2.3 roughly. Okay. So this you just stick right into your calculator and let your calculator do the work for you, and you get approximately 98.868. Okay, so that's part A. Part B, I'm going to go back to my graph here. Now, what they're telling you is you've got these isosceles right triangles, which means that you're taking these cross sections that look like this, and then it's not a great picture, but that is the isosceles triangle, where this guy, this is the base and this is the height. But since the height and the base are equal, they're both, quote, the base. And the base will just be the difference, or the distance between this line and this curve, which we know, right, if it's the difference between this line and this curve, that would just be, the base would be 4 minus x to the 4th minus 2.3 x cubed plus 4. Okay? And if you rewrite that so you make sure that you put it correctly into your calculator, that'll be negative x to the 4th plus 2.3 x cubed, right? And that's it. Because the 4's will cancel. So again, I go to set up my integral. It's from, 0 to 2.3. Now, remember, the area of a triangle is 1/2 base times height. So here, that's 1/2 of negative x to the 4th plus 2.3 x cubed. It's squared because the base equals the height. So it's just something times itself. And again, you should plug this right into your calculator, and you get roughly 3.574. Part C really isn't so bad either. So if you take your graph again, and they're saying you have this line x equals k, that divides the region into that divides the region directly in half. You're really lucky here because they tell you the x value, which is going to be one of the limits of your integrand. So basically what they want you to do is set up an equation where this area equals this area. So first you can find the area of this one, right? If this is 0 and this is k, then we know that this is just 0 to k, 4 minus, or we can use our x to the 4th x to the 4th minus 2.3 x cubed plus 4 dx. And that'll just equal the other side, which is this is k and this is 2.3. So that should just equal k to 2.3 of 4 minus x to the 4th minus 2.3 x cubed plus 4 dx. And that's all they want you to do. They just want you to set it up. So this is fine. And if you have one of, like, this, if you have this one minus this one equals 0, that's fine too. Okay, so that's problem 2.